Hello everyone. Welcome to my new video. Today, we're exploring a vulnerable machine called BlackWidow. This machine is part of a single series and is categorized as medium in terms of difficulty. To get started, head over to the VulnHub website and download the vulnerable image. If you're not familiar with VulnHub, take a look at our VulnHub playlist for some useful tutorials. Settings up. Once you've downloaded the image, the next step is setting up the server in VirtualBox. This process is quite simple and involves importing the OVA file into VirtualBox using the Import Appliance feature. Importing the OVA file into VirtualBox is a straightforward process. Here's how to do it. Launch VirtualBox. Click on Files and then click on Import Appliances. Choose the downloaded OVA file from your computer. Click Next and review the appliance details and settings. You can adjust them as needed. Click Finish to start the import. Once the import is finished, you'll see the BlackWidow vulnerable machine listed in the VirtualBox Manager under the VulnHub group. Select the virtual machine, go to Settings, and change the network adapter to Host-Only Adapter. It's important to ensure that both your Kali Linux machine, used for attacks, and the vulnerable machine are connected to the same network. So make sure they're both connected via the host-only adapter. Now, it's time to start the VM. Now, you'll notice that our vulnerable machine is ready, with a login prompt awaiting. Let's dive into the fun. Enumeration. The initial step in our attack is enumeration, which involves identifying the IP address of our target machine using netdiscover. To execute this, open a terminal and run netdiscover-i followed by specifying the network interface name, which in this case is ETH1. From the scan results, we've obtained our target IP address, 192.168.95.16. Next, we'll conduct a network scan to identify open ports, a crucial step in the enumeration process. This helps us understand the attack surface and strategize targeted attacks. We'll use the popular nmap tool for this task. Run nmap-sc-sv followed by specifying the IP address. In this command, -sc is used to perform a script scan using the default set of scripts, while -sv enables version detection, allowing us to identify which versions are running on which port. After completing the network scan, we found 5 open ports. Port 22 TCP, OpenSSH is running here, allowing for secure shell, SSH, access. Port 80 TCP, HTTP and Apache web server is running, but the default page doesn't have a title, suggesting it might be a default or misconfigured setup. Port 111 TCP, RP clients several RPC services, including NFS, Mount, and Lockmer, are available. This could indicate a network file system setup. Port 2049 TCP, NFS network file system is running, which might allow for remote file sharing. This could be a potential target if not properly secured. Port 3128 TCP, HTTP proxy the Squid proxy server is running, but it returned an error page, indicating it might be configured for specific use or restricted access. Now, let's explore the web content hosted on port 80. Open a web browser and enter the target's IP address in the URL bar. After analyzing the web page, we didn't find any additional links or pages that might reveal potential vulnerabilities. To investigate further, we'll use directory busting to uncover hidden or hard-to-find directories and pages. For this task, we'll use the Burp tool. Using Burp, I identified an important directory called Company, which looks suspicious. Let's visit this page. Upon accessing this directory, I found another website built with Bootstrap, which I confirmed using Wapalizer. On this website, every link is static except for the Get Started navigation link. Clicking on Get Started results in a "We're having trouble finding that site" error, indicating that we can't connect to the server at BlackWidow.com. This type of error appears due to two underlying reasons. The first one is, if we have mistyped the URL address in our URL search bar, so that the DNS servers can't find the associated IP address for the mistyped name, or the second reason is, we never entered any hostname into the search bar, but the website expects us to. We can fix this by modifying the local DNS file named hosts located in the etc directory. Open a terminal, type nano, and then specify the path of the host's file. Now, add the IP address with its associated hostname in the hosts table, which would allow your web client to visit the website that was previously reporting an error. Now save it using Ctrl+X and hit Enter. Once this configuration is complete, reload the target's web page to verify if it loads successfully. Since the requested hostname now has an association in the host's file, the website should load without any issues. Now, let's see if there are any vulnerabilities. Upon inspecting the page source, I found a clue from the developer mentioning a file parameter for file inclusion. This suggests there might be an LFI, local file inclusion, vulnerability. LFI, local file inclusion, vulnerabilities can allow us to access sensitive files on the server. To verify this, we'll conduct further tests to identify any LFI vulnerabilities in the URL. From the page source, we identify parameters that can be used in the URL. These parameters are usually denoted by a question mark, followed by key-value pairs. When I tried simple key-value pairs, I didn't get any useful results. So, I'll use ffuf, an automated fuzzing tool, to test various payloads in the key-value pair and identify potential values. First, we need a proper word list for LFI, as the pre-built Kali Linux word list doesn't include one. The Seqlist's word list is commonly used for this purpose, but it doesn't come pre-installed on Kali. Visit the Seqlist's GitHub page to download the word list. Now, use the following command on the terminal. Where -u is used to specify the target URL for fuzzing, -w is used to specify the word list containing the payloads to be tested, -c is used to color output for better readability. -ic is used to ignore word list comments, -r is used to follow redirects while fuzzing, and -fs is used to filter responses based on HTTP status code 0, that is, show all responses. The ffuf scan successfully identified an LFI vulnerability in the application. The tool managed to read several sensitive files on the server. Among these files, the etc/password contains user account information. etc/group contains group information. cmd line, stat, and status within the proc/self directory path contain information about the running process. var/log/apache2/access.log contains Apache server access logs. Let's take a look at one of these files, specifically etc/password. Upon accessing it, we discovered the target's password file. This indicates that the application does not properly sanitize the file parameter, allowing an attacker to traverse directories and access files outside the intended directory. This vulnerability could be exploited further to gain more information about the system and its users, and potentially gain a foothold on the server. Foothold. Upon inspecting the output of ffuf, I found an unsanitized file that contains Apache server access logs, indicating a potential log injection vulnerability. Upon accessing the Apache2 access log file, I discovered that it contains detailed information about requests made to the Apache web server. To gain a foothold, we need to inject malicious code into the logs. This involves sending a request with malicious code in a field that gets logged, such as user agent or referrer. For this purpose, I'll use Burp Suite to observe the behavior of the injection in the Apache 2 access log. So, launch Burp Suite from the Kali menu, and configure the browser's proxy settings using Foxy Proxy. Access the Proxy tab, and activate Intercept mode to capture target requests. Switch the proxy to Burp Suite within the Foxy Proxy extension. Now, reload the page to intercept the request data, then send the captured request to Burp Suite's repeater tool. When we send the request, we get the logs of previous inputs in the response section. Now, it's time to inject a payload into the logs. This can manipulate log files, disclose information, and potentially allow remote code execution if the logs are not handled correctly. To do this, we inject the RCE PHP code snippet into the log files by making a request with the code in the user agent or another HTTP header. This can help us see if the server logs are vulnerable to code injection. Now, it's time to trigger remote code execution. After injecting the PHP code, include the CMD parameter after the access.log file in the request to execute system commands. Here, I will use the ID command to test this. When I send this data, we receive the user and group names and numeric IDs, UID or group ID, of the current user, which is www.data, in the log file. Next, it's time to execute malicious code to get a reverse shell. For this purpose, here, I will use a bash reverse shell script. Let me change the listening host IP address with my Kali Linux host-only IP address, and set the listening port to 4444. Before sending the request to execute this setup, I will turn on a listener using Netcat. After that, send the request to gain a shell. Initially, the shell request didn't seem to work, so I decided to encode the URL to see if that would fix the issue. I used an online URL encoder for this purpose and then sent the request again. This time, I successfully got the shell. Let's check if we can access the user flag. First, let's change to the home directory. When I list the files and directories, I find a directory named Viper, which seems to be the target's username. Change to the Viper directory and list its contents. However, when I try to access the user flag, I get a permission denied error. Additionally, there is another file in the directory that looks suspicious. I attempted to access it, but, again, I do not have the necessary permissions. Next, I decide to look for any backup files in the web directory, but I don't find anything suspicious there. I return to the previous directory and navigate to the var directory where I find a backup directory that looks interesting. I change into this directory and discover an important file, auth.log. The auth.log contains logs of user login attempts. By examining its contents using the cat command, I see a large amount of data. Given that auth.log contains the login prompts, it's plausible that a password could be hidden within the logs if the admin happened to type it in during login. So, I get the idea to copy this data, modify it into a word list, and then use it to perform a brute force attack on the target to find the correct password. For this purpose, first, I save the output of auth.log to my Kali Linux system using a text editor, and save it as log.txt. Next, I extract words and create a word list by running this command to process the log.txt file, and generate wordlist.txt. Now, I will attempt a brute force attack on SSH, which we identified as an open port from the earlier Nmap scan. I use Hydra for this purpose. We already know that there is a user named Viper. After running Hydra, I discover a valid password. With the username and password in hand, I log in using an SSH client tool. Once logged in, I have user-level permissions. So, let's check for the user flag, and there it is. Next, I try to access the root flag, but I get a permission denied error. This means I need to gain root access to obtain the root flag and complete our lab. Privilege escalation. During privilege escalation, the initial step involves gathering system information to pinpoint potential vulnerabilities or misconfigurations that could grant higher access privileges, ultimately leading to root access. To begin, we need to examine the permissions assigned to users to assess their privileges on the system. This can be achieved by executing commands like sudo-l to view the commands the current user can run with elevated privileges. However, it appears that the user Viper does not have permission to run sudo. Let's gather more details by checking the kernel version using the uname-ic command, and searching for any associated exploits using searchsploit. Unfortunately, this search doesn't yield any results. Upon further exploration, a suspicious directory named backup site is discovered within the home directory. To delve deeper into potential vulnerabilities, we'll employ LinPEAS, a powerful tool designed to extract various system information, including SUID binaries and vulnerabilities conducive to privilege escalation. To get started, download LinPEAS from its GitHub repository. Once you have LinPEAS, initiate a Python 3 HTTP server. Switch back to the target server and use the get command to download LinPEAS from the IP address of the machine running the Python 3 HTTP server. If you are unsure about the IP address of your host-only adapter, you can use the ifconfig-eth1 command to find it. But upon running it, I found out that, on the target system, wget is not available. So, to download the linpeas.sh file, I will use the curl tool. After successfully downloading LinPEAS on the target server, use the ls-al command to check if the file exists. Upon inspecting, I discovered that the linpeas.sh file does not have the necessary execution permissions. To resolve this, give the execution permission to the linpeas.sh file using the chmod +x linpeas.sh command. Once the execution permission is granted, run the linpeas.sh file. This time, it should execute without any issues. After running linpeas.sh, the tool will generate output, providing comprehensive information, including SUID binaries, vulnerabilities, and other relevant data to aid in the privilege escalation process. After reviewing the LinPEAS output, I found that the suspicious directory contains a tool with permissions for executing at the root level. To exploit the arsenic binary for privilege escalation, we can utilize its capset UID plus EP capability. This feature enables the binary to alter its user ID to any user, including root. For a better understanding, let's download it to Kali Linux using the SCP tool. SCP is renowned for its simplicity and seamless integration with SSH, facilitating secure file transfers across networks. Let's execute it. Upon execution, the file will be automatically downloaded. Now, let's examine the readable strings using the strings command. The strings command extracts readable text from binary files like executables, object files, and core dumps. It scans the file for sequences of printable characters and displays them. This tool is commonly used in reverse engineering and security analysis to uncover embedded information in binaries. In the strings output, I found a reference to Perl. Finding the reference to Perl within the arsenic binary, which could potentially be significant for privilege escalation. This suggests that the binary might invoke Perl scripts or use Perl in some capacity. To understand how the tool works, I'll run it with the help option. In the help menu, I noticed the -e flag, which have ability to compile a program. Since Arsenic is built with Perl, there's a possibility of compiling a Perl program. Visit this website, where you will find out various shellcodes to gain root. But here, I am looking for capabilities. After copying the code, I'll paste it after the Arsenic binary. Upon execution, it provides a root shell. Now, let's navigate to the root directory to obtain the root flag. That concludes this tutorial. If you have any questions or concerns regarding this video, feel free to leave a comment below.